I would like to present my research work is titled The Crack Zone Simulation of Clay Backfill Under Seismic Load. The work is numerical simulation using advanced software. In the most of the earth structure, they have a problem related to the bearing capacity of the soil, and low bearing capacity of the soil is creating a problem, failure, and or creating problem that the earth's structure cannot be used. And another problem the earth's structure they have is high vibration when the load is applying on the structure, and this high vibration in a initiate the crack in some part of the earth structure and expanding that crack. Another problem they have most of earth's structure are displacement, and the displacement unallowable of displacement lead to collapse of a structure, and displacement is starting based on the high deformation or nonlinear deformation. There is two types of the displacement, linear and nonlinear, and most of the nonlinear is occur based on the applying nonlinear load on a structure, or when the mechanical property of the earth structure from the place to place is different. Here one type of with mechanical property is used, and applying the load is nonlinear load. All of these problems bring capacity, vibration, settlement, or deformation is create crack and expanding the crack. In this research, what I have is a backfill and a concrete earth structure. I would like to simulate only backfill, and crack is developing in the backfill. The crack is developing in the backfill is analytic calculated based on the analytical method and using the simple formula, and the crack is depend on the mechanical property of the soil, is the cohesion of the soil and unit weight of the soil. Of course, integral angle of the friction and other parameter of mechanical property of soil has influence, but two main important part in the soil, two main important parameter in the soil crack are the cohesion and the density. Another important part in the crack is the seismic loading, and seismic load, it need to understand how the seismic load develop crack, and this kind of the crack impact on the displacement of the backfill. In this research investigation, the soil is the clay soil. Focus is on the crack. Crack is developing in the backfill part. Some place is calculating using finite element method software. For this problem need to understand what is impact of the mechanical property of the soil on crack. The seismic load is applying here in X, Y, and Z direction simultaneously. Three important parts of the seismic load are selected based on peak acceleration occurrence in that. The earthquake 6.2 magnitude is used for this simulation and applying load to the model. Only backfill model is showing here because the seismic load is applying on the backfill, and we use the analytical model to realize the crack, and after realizing crack based on that crack with help of the Abogis and nonlinear finite element method, I understand what is displacement, which is very important in the seismic stability of an earth structure. The brief flowchart for this investigation are presenting here. At the first, need to know the crack zone and solid zone of the soil, which part of this soil are crack is going to subject to the crack, and which part it will be solid and no crack it will be developing, and this crack is not impacting to the displacement and collapsing of the earth structure. Modeling, and finally after the modeling and applying seismic load, discussion and suggestion. The suggestion for the improve of the seismic stability of earth. Result of the numerical simulation. In the numerical simulation, we have two models. Model 1 without any crack, and in that strain energy is shown. And the second part is the model with 3 crack. The crack is simulated in the backfill in cracked zone, 3 crack with the same distance from each other. And what is happening to the strain? Less strain energy is needed to collapse when the crack is developing in crack zone of backfill. And the next part, we have the displacement. What will be displacement? In the maximum displacement in the positive direction when we have no crack is near 59, and for cracked is 57, around the 57. But it's a positive direction. And in negative direction, positive direction when they are applying the loading, and negative direction when we are applying reloading. In that part, the backfill without the crack, we have the load of, we have the displacement of minus 11, while in the model 2 with the crack, displacement in a negative direction is around the 21. What will we understand? After applying seismic load in model 2 with a 3 crack, we have displacement, higher displacement total from the positive and the negative direction. Now we want to understand what will be displacement in whole process, displacement of the model or in whole stage of applying seismic load. Here the first model without any crack and the second model with a crack. Histogram is showing with crack in the model, the displacement mechanism is changed, and when the displacement mechanism is changed, the vibration is the change, and displacement is increasing. The displacement increasing with creation of the crack in whole stage compared to when the model has no displacement. In the reality, the most of the soil, clay soil, has a crack when it's placed in the backfill. In the design, to have the real and the correct design of the backfill, which can be improved, understanding of the backfill seismic resistance, we need to understand displacement in whole stage of the numerical simulation, not only one stage, in whole stage. Then when we understand whole stage of the displacement, then it can be understand vibration mechanism of the model. Okay, range of displacement. Range of displacement also here showing with model is a cracked model and the model without a crack. The novelty of this study is related to introduce a methodology for understand the crack in the backfill and impact on the displacement and impact on the vibration mechanism. When we have the displacement, we have two types of displacement, linear displacement and differential displacement. This kind of if we have the differential displacement is more accelerate expansion of the crack. Thank you for attention. If you have any question, please email me.